Example number 3, also an investigation from page 326, and it talks about a cup of water. Okay, before I read this, let's just look at the equation. That equation right here. And let's see if we can figure out what this thing's going to do. It seems like T and M, so that's function notation. Temperature with respect to M must be number of minutes, whatever that is. Okay, so now we have a number, we have a fraction, we have another fraction for the exponent, and then an extra number here, which we didn't have before. So how does this play out? We used to think that this was the starting value. Why? Because when we set the variable equal to 0, this becomes 1, and 80 times 1, it's 80. But now I've got 20, which means that when I set m equal to 0 to find my starting value, this will be 0. 3/4 to the power 0 is equal to 1. 80 times 1 is 80. 80 plus 20, it's 100. So this function starts at 100. My starting value is actually the 80 plus the 20. So the example on the previous example, that we had a 5 here and nothing there, that's why 5 was the starting value, because it was 5 plus 0. So the starting value is going to be whatever it works out to be when m is equal to 0. Make sense? Okay, next. So this 3/4. This 3/4 means that it's 75%. 3/4 means that I lost 1/4. So this, whatever this function is going to be going down, because every time I got one more, I lose 25%. I lose 1/4 of whatever I had before. But how often? Oh, remember that divided by 5? Oh, every 5 minutes. So I start at 100, and from the 80 that I have available, I lose 1/4 every 5 minutes. And that's what all the numbers mean. Okay, so let's see what the situation was. A cup of water is heated 100 degrees Celsius and allowed to cool down to room temperature, 20 degrees. The temperature T in degrees Celsius as a function of time m in minutes can be modeled by the function, which means that if it's 20 is room temperature, that's as low as it's gonna go. That's gonna be my asymptote. Remember that our asymptote used to be y equals 0? Well, now my room temperature is 20. So that last number actually gives us the asymptote, how low it's gonna go. All right, so let's go to plugging numbers in, and I just used some technology for it. I gave you 0, 1, 2, 3, 4, 5, and then I jumped by 5s to get a little bit further. And here you can see it goes like this, and that 20 is going to be our asymptote. Okay? So we already talked about, this is my starting point is 80 plus the 20. 80 is how much I can drop. I can drop 80 degrees. How much am I going to drop? I'm going to drop 1/4. How often? Every 5, in this case, minutes. When you plug it in, make sure that you put brackets on it. Now let's do another calculation. So let's say we're going to go with, let's say we do 10. Okay? So if I plug this in here, it's going to be 80 bracket 3/4. I'm just going to say 3 divided by 4, but that's what 3/4 is. To the power of, open bracket, 10 divided by 5. That would have been easy for me to say 2, but I'm going to reuse this. And then plus 20. Enter. Okay, that's 65. So 10 was 65. If I want to switch it to 25, to do the other ones, just to jump around, I change the 25 for the 10 and hit it, and it's 38.98. On the 20, okay, here, 38.98, this rounds, I rounded it to 39. Cool. So there it is. I'll say it one last time. I know I'm repeating myself, but what this equation means is that I start, when this is 0, with 100 degrees. And then from the 80 degrees that I can drop all the way through to 20, I drop 1/4 every 5 minutes.